Okay. So while answering the questions, we'll anyway review the previous lecture. So let me start by going over the questions that you had, right? One of the questions was, can the interface have any default method implementation? So in this class, we'll be seeing one of the ways to do it, which is the superclass, right? Inheriting from the superclass. So the question was, if there are some methods which will, let's say interface has some methods declared, but if the implementation is more or less same for multiple classes, so then we can we have a default method implementation. So if there is no implementation provided by the class, the implementing class, for that particular method, then even in that case, it should have some default method implementation. Um, so if you are not, I hope you can see my Eclipse screen. So let's say, so if you define an interface, the question was, can you have something like this, right? So let's say I have I method, I don't know, 5. So can you have something like this, which is not possible. So you cannot have uh, a method definition inside an interface. You can only declare it and you cannot define it. So this is, so you can only declare it in the sense that you can mention the signature of the method, and then the body would be empty. So you put a semicolon here. So for that question, the answer is it's not possible. So you cannot have default method implementation. But as we will see later in today's lecture, there are other ways to do it. So the other way would be to have a superclass, right? And in superclass and subclass, which we will discuss later, you can have um, in the superclass a method definition also, right? Okay, so that was the first question. The second question was about one interface implementing the other interface. Um, okay, so here, let's say there are again more than one interface, and if you want to have the other interface sort of inherit or have some characteristics from the previously defined interface, right? Then is there a way to extend that or implement it? So here one interface cannot implement the other interface because if you implement it, as we discussed earlier, it's like a contract, right? You need to, the implementing class or here the interface needs to provide the definition for the method. So for example, if you replace this with implements, then it's mandatory to provide the uh, definition for all the methods in the test interface one. So test interface one has only one method, which is I method one. So now you need to provide the definition for I method one. But as we discussed just now, it's not possible, right? You cannot provide the definition of the method. You can only provide the declaration of the method. So in that sense, you cannot, one interface cannot implement the other interface, but it can extend it. So extends is again something that we'll be looking at in this lecture, right? So extends is used for inheritance. So you can say that this interface inherits the characteristics or the methods from the interface one. So now you can assume that test interface 2 has both the methods, which is I method 1 and I method 2. Right? So now whichever class implements test interface 2, it needs to provide the definition for both the methods. So for the answer for the second question is, it cannot implement the other interface, but it can extend it. So in terms of the intention, the question was, can we reuse some of the methods in the earlier interface, from the other interfaces? So in that sense, you can implement that kind of the intention, right? So this interface would now have all the methods that are declared in test interface. So are there any questions so far before I move on to the next question? Private methods. Yeah, you can have private methods, but it's not that useful, right? Like, because there is no way to make use of them, because interface cannot have an instance, and interface cannot have method definitions. So, and if you declare it private, it's not accessible beyond the interface. So the implementing class cannot access them. So it's blocked, right? It's almost as good as not having them. So it's not useful in that sense. So that's why even if you declare some variables, right, they are all generally declared as public. Okay, so let's move to the third question, which I think there are lots of questions on, and we also end up spending a lot of time, right? So the question was, uh, okay, so let me go back to the slides. Okay, so here, let's say you create an object you of type transporter, but in the method, and that instance is passed to the use transportation method, but in the use transportation method, you are having the bike or the car as the instance, as the type, sorry. So in this case, can we call the methods of the bike or the car here? So that was the question. Okay, so let me go back to the code. Okay, now that we have declared two interfaces, right? So we have test interface one, which has one method, which I declared, which is I method one, and test interface two now extends test interface one, and it has I method two. So I declared I method two, but since we extend it, it also has I method one. So this has two methods now declared in test interface two. And now we have a class called class one, and it implements test interface two. So since we are implementing test interface 2, it has one method which is declared here, and one method which it inherited from test interface 1. So it needs to provide the definitions for both the methods, I method 1 and I method 2.
The declared type is of transported.
Sorry, was that a question for me? Okay, so let me move on. And this class also has a few methods of its own, right? So it has C method 1 and C method 2, which have been defined within this particular class. So there are two methods which are defined to satisfy the constraint of the interface. So these are from the interface, so, and that's why you have this override annotation on top of it. And there are two methods that are defined within class 1, right?
Excuse me, sir.
Yes.
If we didn't provide the definition for I method 1, would there be an error?
Yeah, there will be an error. And yeah, because, okay, you can remove this and check, but yeah, this is complaining, right? So it says that it should implement all the methods, inherited method also.
Okay, sir.
Okay, so yeah, so these are the two methods, and then to test our the question that you had, I mean, some of you had from the last class, I created two more methods. So one is the test interface method calls one, and test interface method calls two. So in the first one, it takes the interface as a type, so which is test interface two, and in the second one, it takes the class as the type, class one. So this is the question that you had, but yeah, we can also discuss this, right? So,
excuse me, sir.
Yes.
Sorry to interrupt. I think so. This was a doubt in the previous class too. I did not get it quite. So can you explain the significance of override in the sense if I don't write it, then what will happen? Will it automatically identify that it is an interface method?
Yeah. That's right. So here it doesn't matter. So let's say remove this. There is no error as such, right? So override annotation is like a signal, as we discussed. So it's just a signal to the compiler saying that, okay, now uh, give importance. Overriding is giving priority, right? Giving priority or importance to this particular definition. So it helps the compiler uh, in that sense. But even if you don't do it, at least for the compiler, it doesn't matter. But for the humans who are reading the code, it's a lot more clear, right? For example, if you remove this, then there is no difference between I method 1 and C method 1, right? But here, when you say override, that means you will immediately recognize that, okay, so this is a method that has been, so there is already a method that is either declared or defined here. So in the case of extends, right, later on when we see the inheritance, so you will be extending another class. So even in that case, you will be inheriting the methods from the extended class, from the class that you are extending. So you can say that give importance or priority to this method definition rather than the one that you inherited. So if you look at this, if you're reading this code and if you look at the override annotation, you can easily figure out that, okay, I method 2 has been declared here. But if you take a look at I method 1, it's not clear whether this is a method 1 that has been implemented by or it belongs to class 1 or it has been inherited from some other place. So it just helps the uh, person who is reading the code or maintaining the code. It is so in that sense, it's a good practice, and it also provides a signal to the compiler. So
So
at
if
least in Eclipse, you find these small turtle symbols, right? So those are also indicators. So that's like overriding, but again, it may not be present in some other IDE. So it's good to have this override annotation. Yeah, are there other questions?
so if we have this override sign and I make another method with the same name, I method 1, will that be legal?
Oh, with the same signature? No.
Yeah.
You need to, you cannot have the same signature. You can change it. So in the sense, you can, let's say, for example, add a few parameters to the new I method 1, but you cannot have the same signature twice.
Okay.
Excuse me, sir.
Okay, so yeah.
Sir, if a class is implementing an interface and that interface contains, let's say, an integer which is initialized to some value, so that class cannot change the value of that particular integer, right?
So if an integer has been declared in the parent class, is it? And then you are extending it, or can you
No.
repeat?
I mean to say that if there's an interface and in that interface there is a declaration, let's say int I equal to 1, and then a class is implementing that interface, and inside that class can we change the value of that I, integer I, or it will remain the same?
No, you can change. So it depends on. So let's say if you have it as a constant, which is a final, then obviously you are not supposed to change it, or you cannot change it. But if it's not a constant, then you can change it. But it should be public, right? So in the interface, you declare it as a public instance variable, and then you can change it. Okay, so yeah, let me go over this one. So here you have, so I created one object which is of type test interface 2, but it has been assigned the instance of class 1, right? And now I created one more instance which is of type class 1, and it's called COBJ1, right? Okay, so now I'm calling these two these two methods here using the instance of class 1. So in the first case, I'm passing the interface, sorry, the instance that has type test interface 2. Let's see how that goes. So here you are simply, so that means you are calling this method, right? And since it's of test interface 2, it can only access the IMethod1 or IMethod2. So for example, it cannot, you can see in this way. So it doesn't have access to, say, C method 1 and C method 2, which are these two, because it does not have that kind of visibility, right? Okay, in the next, so we discussed this part in the last lecture as well. So this was the question, right? So in this case, we are passing in the object of type interface 2. But here we are saying that the instance should be that it is expecting is class 1. So if you directly pass, say, let's say you create one more. Sorry, yeah. So if you don't typecast it and then just pass it, it doesn't even accept it. So it complains saying that the method, the method is expecting arguments of type class 1, but you are passing an argument of type test interface 2. So it doesn't even accept it. You need to, that's why you need to try. So that's why I did that. So now you are casting it as class 1 and passing it here. And now since C1 is of type class 1, you can access any method. So it can be a method that you got from the interface, which is IMethod1, or it can be a method of its own, which is C method. Right? So once you have this, it has access to all the methods basically. Right? So it has C method 1, C method 2, or IMethod1 and IMethod.
Excuse me, sir.
Yes.
Could you make one small change to the code? Can you
Yeah.
write something like class 1 C object 2 is equal to the parameter you passed? Like in
Sorry, what's that?
yeah,
Class 1.
class 1 C object 2 C obj 2. Okay, C
Okay.
C is equal to
And I should create it.
No, you should not create it.
No.
Brackets class
Okay.
1 brackets class 1 and T obj 1.
Okay.
Would it work then?
Yeah, it's the same, right? This is same as. So you want to send COBG2 here.
Uh, yes, sir. No, sir. I'm just asking, like,
Huh.
so now I can typecast any interface object into its superclass. I think so. That's what I'm trying to conclude here.
Yeah,
It's
that's right.
not
So
this.
class 1 has implemented as long as it implemented that interface, yeah, you can typecast it.
Okay. Thank you, sir.
So so TOBJ1, although it's of type test interface 2, it is pointing to the instance of class 1. So, and class 1 has implemented test interface 2. So in that sense, you can typecast it and then make the assignment. So this statement is same as whatever I have written, right? So we have just assigned it to COBJ2.
Sir, one doubt.
So yeah.
Suppose we have an interface transportation, transporter, and then we have two classes, car and bike, and they both implement transporter.
Okay.
So can we typecast car into transporter?
No, the other way is not possible, right? Because interfaces cannot have instances.
Oh,
So
okay.
that we discussed in the last class. So for example, so so here there are two interfaces that this class is implementing, laptop. And the reason this option A is not correct is because it's creating an instance of type interface. So it's creating an instance of typeable, which is interface, and that's why option A is not correct. So among the options here, only option D is correct, right? Because your first line is correct. You are assigning the instance of the class, which is laptop, to the interface type interface called clickable, and then your since clickable can only have access to click, you and not type. It's okay to call click. So that's why only option D is correct here. So are there any other questions before I move on? Okay. So if you want it, I can post this code on the classroom, but if it's okay and if it seems straightforward, you can implement it by yourself as well. And I'll keep posting it on classroom. So whatever you want, right? So whatever is, it's up to you. So you can send me an email or you can let me know now or by the end of the class. Okay, so I'll move on now with the rest of the lecture from last class, and then we'll start with the inheritance. Okay, so in the last class we discussed about two types. One is the declared type and the other one is the actual type. So declared type is the interface, the transporter here, and the actual type is the car or the bike.
Sir,
Yes.
why the option C is not correct in the previous question?
Option C. Because it's typable, so the here the assumption is, so it's not given here, but the assumption is typable interface has only type declared within it, and clickable interface has only click declared within it. So typable can only see or access type, because that's what is the only method declared within it, and clickable can only access click. So here we are saying that the MacBook is of type typable, but we are calling click on it, and typable does not know about click, and that's why it's not correct, right? Okay, so um, so here yeah, the interface is the declared type and the implementing class is the actual type. So using this declared type, we can refer to objects of all these actual types, right? So let's say there are 10 more types that have implemented transporter. We can use this transporter to refer to all these 10 separate objects. So you can keep it general using this declared type. But the disadvantage that we have seen is it can only have access to the methods that are declared within that interface, right? So on the other hand, using the actual type, you can have the specific implementation level details. So in this case, we have the move method. So the way car moves is different from the way bike moves and the train moves. So that implementation level details can be delegated to this particular implementing class, right? So here, yeah, the actual type changed from car to bike, but we can still refer to these actual types using this declared type. Okay, so the other question that there can be is when to use this polymorphism. Okay, so whenever you have these common things that you can put together, first is to create that interface. So all the common parts go to this interface. And then you can have multiple different classes that have some common functionality, but they are implementing or they are having the implementation in their own way. Move example. So the common thing is that both of them move, right? So if you hide the common parts, then you can have this polymorphism. And the other use cases, if you expect that in the future there can be more types, more things in the common. Let's say apart from car, bike, which is what is there currently. Later on in the future, you can have train, I don't know, horse that we discussed, flight, bus. So if you don't use polymorphism in this case, you will end up creating lots of separate methods. So if you think that, that's one possibility in the future, that there can be extensions, it's a good idea to go for polymorph. So this is like a summary, right? So why do we use interfaces? So if you want to enforce a few things, like if you want to say that move is something, is a method that should definitely be implemented by all the types, in this case all the vehicles that move. So then you make an interface, and then you make a class implement all these interfaces, right? Then it should definitely provide the definitions for the methods defined in these interfaces. So it will guarantee that a class has these capabilities that have been declared in the interface. Right? Even though say the car class may or may not have other methods, but it should definitely have the move method. So that's the advantage. And in the case of polymorphism, you can have these implementation agnostic classes and methods. So that means that you can only focus on the move part, and then delegate the specific uh, definition or the implementation of move to the respective classes. Right? So in that sense, from the abstract level, you can only say that we are interested in the move, but not how it moves. So that is the implementation agnostic details. Right? So polymorphism, you can have that kind of abstractness when you use this polymorph. And these are also what is called as generic programming. Right? So you are not tying it up to specific types, but it's more general. And you can later on, even if you extend your functionality to include, say, bus and train, you don't need to change this part of the code. So you can only worry about the rest of the code, which needs some changes. Yeah, so we already sort of discussed this, right? So if you don't have the polymorphism, then you will end up with lots of other classes and methods, like using roller blades, bikes, use bus, train, and so on. But with this new design, at least part of the code is fixed. You don't need to change it. So this is the racer part. So the racer code can remain the same, irrespective of whether you add a new class called bike or bus or train. So that's the advantage. So it's less work for you, and it's easy to maintain as well. So this is the complete program. So going back to the initial example, right? So you had two racers, Dan and Sophia, and they are racing from point A to point B. And the other thing is, we are not interested in the transportation mechanism. So the only thing that we are interested in that is that they should reach the destination as fast as possible and possibly win the race. So the goal is to win the race here, and so they can use any transportation that they would like, right? So for our purpose, we have considered only car and a bike. So at the level of the racer, we are not interested in the type of the transportation that was used. So that's why we create an interface with a move method. And now to call this use transportation, they can use any transportation mechanism. So it can be a car or a bike. So Dan in this case used a car, Sophia used a bike. So it's up to them. So you only change this part of the code. Let's say later on Dan wants to use a bus and Sophia wants to use a horse. They only this part needs to change, and the racer, this can always be fixed, right? This, you need not change this part. So that's the advantage here. And we have also seen the composition and association parts here, right? So here you have declared the instance level variables, and in the constructor you have created an instance of it. So what is the relationship now between race and racer? So is it composition or an association or a dependency? So yeah, one of you can unmute and tell me, or
Composition.
Yeah, that's right. So yeah, it's a composition because you have created the instance uh, in one of these methods and assigned it to the instance variable, right? So if the race instance dies, then automatically Dan and Sophia instances will also die. Okay, so that's so this is just a brief summary of this entire lecture, right? This topic at least. So I mean, we went over all these. So interfaces are like contracts. So it will force the classes to have certain responsibilities or capabilities. So if you want these classes to definitely implement some of these methods, then you should have the interface and then make the class implement this interface. And polymorphism, as we have seen, it allows for this implementation agnostic uh, um, behavior, and you can have this generic type implementation as well. So you only worry about the abstract level details and not the very particular details. So that's the advantage. And then you can have a combination of polymorphism and interfaces to implement this generic coding style. And that will help you to at least fix some part of the code. And if there are some changes, only the other parts of the code needs to be changed. So in that way, you can have a clean code. And since you don't have to change too many things, it's easy to maintain as well.